Okay, so this video is going to be about the VSEPR, and it's going to be about VSEPR when we have 6 electron groups. So when we have 6 electron groups, our base shape is an octahedral, and I'm going to start out with when we have 6 bonds. So I'm going to draw my central atom here, and the way I like to draw the octahedral, I'll draw 2 on an axis sort of 180 degrees apart from each other. And then I like to draw 2 of the bonds coming out at you, and 2 going behind. So we'll go ahead and do that. And I will say all the angles here are 90 degrees. And I'm using the PhET simulation. So up here I have the PhET simulation, and you can see, right, molecular geometry, electron. So electron geometry is based on the number of electron groups. So we have 6 of them, so that's an octahedral. The molecular geometry, again, based on, they're all bonds. So the electron geometry, the shape, the molecular geometry, whatever you want to call it, is based on an octahedral. And I'm showing you the bond angles over here. So I'm just going to go ahead and rotate this around a little bit. So I've taken the molecule and drawn it the way I've got here. So so this one coming out would be this one over here. This one coming out would be this one over here. This one in the back would be this in the back would be this, and then I've got, right, these 2 on an axis. So I'm just going to rotate it around a little bit so you can kind of see that there are 4 in a plane, right, around sort of the middle, and then the ones up and down, and I can rotate that around. It's a very symmetrical molecule. So this molecule has a lot of symmetry. Again, I'd encourage you to go to the PhET site and play with it. If you just type in PhET, PhET, and then molecular shapes, you should be able to find these simulations to run on your own computer. But, you know, it's a very symmetrical molecule. Okay, so let's think about what happens if one of these is no longer a bond but becomes a lone pair. So again, I know that, right, lone pairs, right, want as much space, right, as possible. So I need to think about which one of these is no longer going to be a bond and be a lone pair. And it actually turns out this molecule is so symmetrical that all 6 positions are exactly the same. So, you know, if you're taking your model, you've made your octahedron, you're trying to figure out which bond goes away, it doesn't really matter. So I'm going to go ahead and do that in my PhET simulation up here. So I'm going to remove a bond, I'm going to add a lone pair. And you'll be able to see I've changed the shape. So now the electron geometry, there's still 6 electron groups around it. I've got 1, 2, 3, 4, 5 bonds, 1 lone pair. So electron geometry is still an octahedral, but the molecular shape is now a square pyramid. And let me go ahead and I'm going to just kind of erase what I've got here to write things down for you. So we've got that here. So base shape is still octahedral. I'll still have 6 electron groups, but now I have 5 bonds, right? 1 lone pair of electrons. And what it's going to look like, and I'm going to go ahead and draw it. Here's my central atom, right? Here's one at the top. I'm going to draw it this way. I'm going to put the ones coming out at you and the ones behind, right? And I'll put the little dots in so you can see there. And then my lone pair is going to be down here. And again, I'm going to go ahead and draw it again up here in the PhET simulation. Oh, it remembered it, perfect. And so I'm going to just rotate that around so you can kind of see I have the lone pair up here. The way I've drawn it on my piece of paper is like this, with the 2 coming out at you and the ones going behind. So that's there. And, you know, you can kind of see everybody's still sort of 90 degrees apart from each other. Okay, and it's a square pyramid, so it has a base here that's a square, and, right, one sticking up, and if you kind of thought about what this would look like as a solid object, it would indeed look like a pyramid whose base was a square. Okay, so that's the square pyramid. So now I need to think about which of these positions, and maybe I'll put my little pointer here, right? So these 4 in the square are equivalent to one another. And then I have this one sticking up here. So I'm going to argue that I've got 2 different places where I could put the next lone pair. If I take away a bond, put in another lone pair so that I've got 4 bonds and 2 lone pairs, I want to put the lone pair as far away as possible from this lone pair that already exists. So these would be 90 degrees. This position would be 180 degrees. So where does the lone pair want to go? It wants to go as far away from possible as this lone pair, so it's actually going to go up here. So you can see that when I take away a bond, let's see, I got to make sure I'm in the right thing. When I take away a bond, add another lone pair, and you can see what happens is I'm now left with a molecule, right? It is, we call this one square planar, and you can see that down in the bottom. But with 4 bonds and 2 lone pairs, I get square planar, and you can see the 4 atoms, and I'm going to get my pointer out, right? These 4 are in a plane, right? The lone pairs are here. So let me go ahead and write some of that down, and I will get my eraser to erase some of what I have before. So we still have the same base shape is, right? There's still 6 electron groups, but this time there are 4 bonds, right? 2 lone pairs. And so central atom, right? A wedge, a dash, right? So this is where the bonds are going to be in that plane together, right? So this is called square planar. And then up here I have a lone pair, and down here I have a lone pair. And if I go back here, hopefully it will remember, yes, there's the square planar molecule. Okay. And the bond angles, right, 90 degrees in that square plane. Okay, so now I have to think about what happens if I take away another bond and have another lone pair, right? 3 lone pairs. It's going to be one of these bonds. All 4 of these, you can probably tell, are equivalent to each other. So I'm going to go ahead and see what happens when I go ahead and take away a bond, add another lone pair. And you can see what kind of molecule this is, what's left behind. And you've seen this one before with the 5 shapes of VSEPR. This is going to be a T-shaped molecule, right? So I will still have, right, 3 bonds here and a T-shaped. And now this gets the lone pairs as far away as they can from each other. So I will write that down. I'll erase what we had for 4. So I'm going to erase this. So if I have, right, 3 bonds, right, 3 lone pairs, right, now I'm going to kind of have here something that looks like this, right? So here's the T-shape. So the molecule will look T-shape, and there'll be a lone pair up here, there'll be a lone pair coming out at you here, and a lone pair behind. So again, I'll show it to you up here in the PhET simulation, right? So that's kind of how I've drawn it. Got the lone pair at the front, the lone pair behind, lone pair sticking straight up, and the bonds there. So that's the T-shaped molecule. And again, the goal is to get those lone pairs as far apart from each other as possible. So you might think about, well, what happens? Well, if I need to do this one more time, and that's all we're going to do it, right? One of these 3 bonds is going to go away, right? And I want to get the lone pairs as far away from each other as possible. So is it going to be this one, or is it going to be one of these 2? Think about what your guess is going to be, this one or one of those 2. Where's the lone pair going to be far away? So I'm going to go ahead and do that in the PhET simulation. So take away a bond, add a lone pair, and lo and behold, look at that. I've got a linear molecule now. So you can see down here, right? Electron geometry is still, it's based on an octahedron, right? It still has 6 groups. So I've got 2 bonds, 4 lone pairs, but the molecule's actual shape, it's going to look linear. So it looks linear when you do that. So I will just go ahead and write that down. So let me erase what I had before. So when we have, right, so when we have 2 bonds, right, 4 lone pairs, right, what we end up with is, right, here's our central atom, and I guess I will draw it this way this time. Right, so I'm going to put this one, this is a lone pair coming out at you, another lone pair coming out at you, lone pair behind, a lone pair behind. And I'll just go ahead and put it back in the PhET simulation. And this guy is going to be linear, and I should write that down, that it is, helps if you can write linear. So those are what to do when you have 6 electron groups and you want to do some VSEPR shapes. And that's the end of this video.